Electricity is all around us. From the lights in your home to the device you're watching this video on, electricity powers nearly everything in our daily lives. But have you ever wondered how this invisible force is measured and controlled? One of the key concepts in understanding electricity is the idea of resistance, and that's where ohms come in. But what exactly do ohms measure, and why should you care? Whether you're tinkering with electronics as a hobby or studying electrical engineering, understanding ohms is crucial. It's not just about numbers on a multimeter, it's about understanding how electricity flows through every wire, circuit, and component, shaping the very devices we rely on. In this video, we'll dive deep into the world of ohms, unravel what they measure, and explain why they matter in practical terms. By the end, you'll have a clear grasp of how ohms fit into the bigger picture of electrical resistance and why this knowledge is essential for anyone working with or learning about electronics. So, if you've ever been curious about what those little squiggly symbols mean on your circuits, stick around. We're about to break it all down and make it easy to understand. Let's start with the basics. What exactly is an ohm? In simple terms, an ohm is a unit of measurement that tells us how much resistance an electrical component offers to the flow of current. Imagine water flowing through a pipe. If the pipe is narrow, the water flows more slowly, facing resistance. Similarly, in an electrical circuit, resistance slows down the flow of electricity, and this resistance is measured in ohms. The concept of ohms is rooted in Ohm's law, a fundamental principle of electronics discovered by the German physicist Georg Simon Ohm in the early 19th century. Ohm's law states that the current flowing through a conductor between 2 points is directly proportional to the voltage across the 2 points and inversely proportional to the resistance between them. Mathematically, this is expressed as V equals IR, where V is voltage, I is current, and R is resistance. This equation forms the backbone of electrical circuit analysis and is used in everything from simple household wiring to advanced electronic devices. But why does this matter? Understanding ohms helps us figure out how much resistance is present in a circuit and how it affects the overall flow of electricity. For example, in a simple circuit with a battery and a light bulb, the resistance of the bulb's filament determines how bright the light will shine. If the resistance is too high, the current will be too low, resulting in a dim light. On the other hand, if the resistance is too low, the current could be too high, potentially damaging the bulb or the circuit. In practical terms, ohms are essential for designing circuits that work correctly. Whether you're building a simple project with a few resistors or designing complex electronics like computers and smartphones, knowing the resistance in your components is crucial. This understanding allows you to control the current and voltage in a circuit, ensuring everything functions as intended without overheating or causing damage. For example, resistors are used to limit current, protect components, and divide voltages in circuits, making ohms a key factor in their selection and application. To put it all together, ohms are a measure of how much an object resists the flow of electricity. This resistance is key to controlling the behavior of electrical circuits, making ohms one of the most fundamental concepts in electronics. Whether you're just starting or have years of experience, grasping the concept of ohms is vital to mastering electronics and electrical engineering. Now that we know what ohms are, let's explore why they matter. The concept of ohms isn't just a theoretical idea confined to textbooks. It plays a critical role in real-world electronics. Understanding ohms helps us predict and control how electrical devices will behave, which is essential whether you're working on a simple hobby project or designing complex electronic systems. One of the most important reasons why ohms matter is because they allow us to manage and control the flow of electricity in a circuit. For example, consider the wiring in your home. The resistance of the wires, measured in ohms, affects how much current flows through them. If the resistance is too high, the wires could overheat, leading to a potential fire hazard. On the other hand, if the resistance is too low, the current might be too strong, potentially damaging appliances or causing circuit breakers to trip. In electronics, resistors are used to control the current flow in circuits. By carefully selecting resistors with the appropriate ohm value, engineers can design circuits that function safely and efficiently. For instance, in a smartphone, resistors help manage the power distribution to various components, ensuring that delicate parts don't receive too much current, which could cause them to fail. Ohms also matter when it comes to the efficiency of power delivery. In any electrical system, there's a trade-off between resistance and power loss. The higher the resistance, the more energy is lost as heat. This is why power lines are designed with materials that have low resistance, minimizing energy loss over long distances and ensuring that as much power as possible reaches its destination. In audio equipment, the concept of ohms is particularly significant. Speakers, for example, are rated by their impedance, which is measured in ohms. The impedance of a speaker affects how much power it draws from an amplifier and how it interacts with other components in the sound system. Matching the impedance correctly is crucial for achieving optimal sound quality and preventing damage to the equipment. In summary, ohms matter because they help us control and optimize the flow of electricity in all kinds of circuits, from simple household wiring to advanced electronic devices. Understanding ohms allows us to design safer, more efficient, and better performing systems. Understanding ohms is one thing, but knowing how to measure them is where theory meets practice. Measuring ohms is a straightforward process that can be done with a common tool called a multimeter, which is essential for anyone working with electronics. To start, let's talk about the multimeter itself. A multimeter is a versatile instrument that can measure voltage, current, and resistance. When you want to measure resistance in ohms, you set the multimeter to the ohm setting, often indicated by the Greek letter omega. Here's a step-by-step guide to measuring resistance. First, turn off the power. Before measuring resistance, ensure that the power to the circuit is turned off. Measuring resistance in a live circuit can damage your multimeter and give you inaccurate readings. Next, set the multimeter. Switch the multimeter to the resistance mode. Most multimeters will have several settings for different ranges of resistance, so choose the range that fits the expected value of resistance. If you're unsure, start with the highest setting and work your way down. Then, connect the probes. Take the multimeter's probes, the red and black leads, and connect them to the 2 points across which you want to measure the resistance. It doesn't matter which way round the probes are connected for resistance measurements. Finally, read the display. Once connected, the multimeter will display the resistance in ohms on its screen. If the multimeter shows OL or 1, it means the resistance is higher than the range you've selected, so you'll need to switch to a higher range. Interpreting the results is crucial. For example, a reading of 10 ohms means there is relatively low resistance, while a reading in the kiloohms or mega ohms range indicates much higher resistance. This information helps you diagnose whether components are functioning correctly or if there's an issue like a short circuit or open circuit. Common mistakes to avoid include forgetting to turn off the power before measuring or using the wrong range on the multimeter. These errors can lead to incorrect readings and potential damage to the circuit or the multimeter. In conclusion, measuring ohms is a fundamental skill for anyone working with electronics. With a multimeter and a basic understanding of how to use it, you can easily measure resistance and ensure your circuits are working correctly. This skill is not just about numbers, it's about ensuring the safety, efficiency, and performance of your electronic projects.